On November 3rd, 2025, a paper went up on arXiv. It looked normal, 81 pages, 4 co-authors, a result on something called the Kakeya conjecture, except 3 of the 4 co-authors were artificial intelligence systems, AlphaEvolve, Gemini Deep Think, AlphaProof. The 4th was Terence Tao, a Fields medalist, the man who 2 years earlier had publicly predicted this would happen by 2026. The paper came out 2 months before 2026 even started. This is the story of the 6-month moment when artificial intelligence stopped being a tool and became a collaborator, the closed loop that made it real, and the 5 mathematical institutes that Google quietly enlisted before any of us noticed. Most of the AI stories you see right now are about money or deals or who's winning. This isn't one of those. This is about beauty. Terence Tao was born in Adelaide, Australia in 1975. By age 9, he was solving university-level calculus. At 13, he won gold at the International Math Olympiad, the youngest gold medalist in the competition's history at the time. He finished his bachelor's degree at 16, PhD from Princeton at 21. By 24, he was a full professor at UCLA, the youngest in the university's history. In 2006, at age 31, he won the Fields Medal, the highest prize in mathematics. The next year, a MacArthur Genius Grant. In 2015, he was in the first ever class of Breakthrough Prize laureates, $3 million from a tech consortium that included Mark Zuckerberg and Yuri Milner. Mathematicians call him the Mozart of math. But here's the part nobody is talking about. In 2023, when ChatGPT first showed up in research seminars, Tao was guarded. He used the early models, but kept his expectations low. After testing OpenAI's o1 in September of 2024, he wrote on his blog, quote, "A mediocre, but not completely incompetent graduate student." Then he made a prediction. In 2023, he had said this on the record, quote, "2026 level AI, when used properly, will be a trustworthy co-author in mathematical research." He gave a specific year. He gave a specific role. He bet his reputation on a date that hadn't arrived yet. 2 years later, in November of 2025, he uploaded that paper to arXiv with 3 AI co-authors. His own prophecy fulfilled before 2026 had even started. And in March of this year, at a workshop at UCLA, he said something nobody expected. Quote, "Artificial intelligence now saves more time than it wastes. Modest, precise, devastating. This isn't a tech demo. This is the moment a Fields medalist publicly admitted the machines were ready." So what actually happened? Google DeepMind built 3 different artificial intelligence systems. Each one does something different. Together, they form a closed loop. The first system is called AlphaEvolve. Think of it as a tireless tinkerer. You give it a math problem, and it writes thousands of tiny computer programs trying to solve it. The bad ones get thrown out. The good ones get tweaked, mixed, and tried again. After millions of attempts, patterns emerge that no human has time to spot. AlphaEvolve doesn't prove anything. It explores. The second system is called Gemini Deep Think. It's a version of Google's main AI that takes its time. Slow, deliberate, careful. Last year, it took the gold medal at the International Math Olympiad, the world championship for the best teenage mathematicians on the planet. 5 out of 6 problems, perfect scores. Deep Think takes the patterns AlphaEvolve discovers and turns them into actual proofs. The third system is called AlphaProof. Its job is to take a proof and check that every single step is bulletproof. It uses a tool called Lean. Think of Lean as spell check, but for mathematical logic. If any step doesn't hold, Lean catches it. If Lean approves, the proof is mathematically guaranteed to be correct. AlphaProof won the silver medal at the International Math Olympiad. The year before, Deep Think went gold. The hardest problem of that year, problem 6. Only 5 out of more than 600 human contestants solved it. AlphaProof did too. Discover, prove, verify, 3 systems, 1 pipeline. Now back to Kakeya. Imagine a needle lying flat on a piece of paper. You're going to slide and spin it around. The rule is, at some point during your motion, The needle must have been oriented in every possible direction. North, south, east, west, every angle in between. The question is, what is the smallest area of paper the needle can cover during this trip? You would think you need a circle big enough for the needle to spin in. You don't. You can do it in an area almost too small to see by zigzagging the needle through clever paths. That is the Kakeya question, posed in 1917 by a Japanese mathematician named Soichi Kakeya. Mathematicians have wrestled with it for over a century. In 2008, an Israeli graduate student named Dvir cracked a cleaner mathematical version of the problem, in a proof so short it fit on 2 pages. Tao called it, quote, a beautifully simple argument. So when DeepMind announced that AlphaEvolve worked on the Kakeya problem, the headlines wrote themselves. But here is the honest version. AlphaEvolve did not crack Kakeya. Dvir did 17 years ago. What AlphaEvolve did was something different and arguably more important. It found a tighter, sharper answer than Dvir's, using geometric tricks humans had missed for 17 years. Then Gemini Deep Think proved the improvement was real math, not just a lucky pattern. Then AlphaProof rolled out the proof, ran it through Lean, and got the verification stamp, line by line, the whole loop, end to end, in one paper, with the AI doing every step. That is the breakthrough, not the conjecture, the closed loop. Mathematicians have been here before. In 1976, 2 researchers at the University of Illinois announced they had proven a theorem mathematicians had chased for 124 years. The 4-color theorem. Every map drawn on a flat surface can be colored using only 4 colors, such that no 2 neighboring regions share a color. The researchers were Kenneth Appel and Wolfgang Haken. The proof was unusual. They reduced the question to 1900 plus specific map patterns that all had to be checked. Those checks took an IBM 370 mainframe around 1200 hours. That was enormous compute for 1976. The output ran to thousands of pages. The postmark on University of Illinois mail that summer read, quote, 4 colors suffice, and the math community split. Mathematician Daniel Cohen wrote at the time, if no human can read the whole proof, is it really a proof? Others worried the program might have bugs. Some celebrated, some refused. The argument lasted decades. 29 years later, in 2005, a French researcher named Georges Gontier did the thing that finally ended the argument. He used a computer to verify every single step of the proof against a precision logic system called Coq. Once a computer had checked it, line by line, the doubt was over. That is the analog. What Apple and Haken needed 1200 hours of mainframe time to compute, AlphaEvolve now does in minutes. What Gontier needed almost 3 decades to do after the proof was published, AlphaProof does as part of the same paper, while the proof is still being written. Every era of mathematics has had an "is this a real proof?" controversy. The verdict every time ends up the same. If a computer can check it, it is real. The checking just keeps getting faster. And now, the same system that finds the proof also checks it. Now, zoom out, because this isn't a one-off result. On October 29th, 2025, Google DeepMind launched the AI for Math initiative. 5 of the top mathematics institutes on Earth, each given access to the 3 AI systems integrated into their working research. Funding announced for at least one of them at $250,000, probably more to come. Imperial College London. That is where Kevin Buzzard runs Lean and Mathlib, the open source library of formal mathematics. He is leading a 5-year, £3 million project to translate Fermat's last theorem, one of the most famous proofs in math history, into a form a computer can verify line by line. The Institute for Advanced Study in Princeton, founded in 1930 by a department store fortune and a $5 million gift. Past members: Einstein, Gödel, von Neumann. Today, David Nierenberg directs it, and its mathematics school has hosted nearly every field's medalist of the last 50 years. IHES, the Institute for Advanced Scientific Studies near Paris, founded in 1958. Today, It has the highest density of fields medalists per square meter on the planet. The Simons Institute at UC Berkeley, founded in 2012 with a $60 million gift from Jim Simons, the hedge fund mathematician. It hosts 150 visiting researchers a year, working on the deepest questions in computer science and math. And TIFR, the Tata Institute of Fundamental Research in Mumbai, founded in 1945 by Homi Bhabha, the cradle of India's atomic program. Today, one of the most important math centers in Asia. 5 institutes, 3 AI systems, 1 initiative. Pushmeet Kohli, who leads DeepMind's science strategy, calls mathematics, quote, the foundational language of the universe. On July 23, 2026, Terence Tao gives a plenary lecture at the International Congress of Mathematicians in Philadelphia, the biggest math conference on earth. The topic, AI. So what does this actually mean? It does not mean mathematicians are obsolete. It does not mean the next Fields Medal goes to a Google data center. AlphaEvolve found a new pattern. Deep Think turned it into a real proof. AlphaProof got a computer to certify it. None of those steps replaced the human question, which is, what should we work on? And why? What it does mean is that the daily work of a research mathematician is changing. Not all of it. The part where you grind through case-by-case checks and endless calculations. The part where you re-verify someone else's algebra to make sure it really does check out. The part where you translate a 100-page proof into a form a computer can check so the community can trust it. That part, the patience work, the verification work, the construction work, machines do faster now, and the humans get to spend their time on what only humans do, asking the right question. In May of 2026, Nature ran a profile of Terence Tao. The headline was 5 words. Quote, the job description is changing. It is not that AI is replacing mathematicians. It is that mathematicians, the best ones, are choosing to work with AI because the math gets done faster. And for the first time in 50 years, every line of it is verifiable. The machines are ready. The mathematicians said yes. If you want to see the next moment, artificial intelligence changes a discipline older than most countries, hit subscribe.